we're gonna plug at it. All right, so I've got 3 problems that I'm gonna work today on the couples type stuff. I think, now you guys, there was it this, well, I guess it was my engineering physics class, that the homework for the chapter was due tomorrow night, and it was, we hadn't even started the chapter yet. And I think we've got that all straight for this class, we've got it all lined out. And you guys are seeing over, Ed, you got the document camera, right? That's what it looks like. Okay, so the problem will work, and we're gonna start showing you how tools, of course, we showed in physics 1, right? We did the plane and the ramp. But I've got a screwdriver this time. So my RT stability here, we got our screwdriver. And at this end of the screwdriver, we're told that this is 5 millimeters away. Okay, from so everybody knows the difference in screwdrivers, right?
What goes to flathead?
That's a flathead screwdriver, right? The one that's got a cross is a what kind of screwdriver? Phillips. Now there are the other nut drivers, which are the hex ones. We've got some of those, and there's the other one.
There's a star.
The star ones.
Torx bits?
Yeah.
That's what the stars are.
Well, but a torque screwdriver is different, even though they might have the star heads, but it's still, the torque is gonna be a little different. Torque screwdriver is a little different.
I think it's the brand name.
Yeah, well, anyway, but we got different heads for different things, right? I was a little surprised that you all didn't know about Allen wrenches, because Allen wrenches are, important things. So this one, now at my house, my grandkids from about the age of 2 know the difference between a Phillips and a flat, and channel locks and a few other things. And this end is 30 millimeters. So we got 30 millimeters on this end, we got 5 millimeters on this end. And what we're gonna do is, we're gonna apply a torque such that, and the torque that we're gonna apply is gonna be this direction, and it's gonna be 4 Newton meters. And we're gonna look at the couple moment on the handle, and we're gonna look at the couple moment on the head. And basically what we've got is a couple moment on the head is gonna look like this, and this is gonna be 5 millimeters apart. And the couple moment on the handle is gonna look like this, and this is gonna be 30 millimeters apart. And we already know that we're doing a force of 4 Newton meters. So if I do this, what we end up with is my moment is equal to R cross F. But we've got, this is perpendicular, so life is good. So we can do this, right? We can do that. And we already have been told that we're applying that kind of a moment, so that's 4 Newton meters. We don't know the force that's being applied, but we do know the distance is 0.03. Yeah, 0.03. I'm just double checking my notes, make sure I haven't screwed up on my conversion. And this means that the force that we're applying is 133 newtons. But we want to see how it translates to this in here, because this is an equivalent couple. What we ended up with at the end of class on Monday was talking about equivalent couples. This thing is attached, right? I mean, I'm attached to a handle, so whatever I apply here is going to be applied there. But I've done something different in order to get there, right? Because it's going to be there, so let's look at what the force ultimately looks like over here. So we know it's a 4 Newton meter force, or 4 Newton meter torque. We know the force is, and this is 0.05, oh, that's 30, that's why it's going. Oh, wait a second, I'm doing crazy today. 005 So the force over here becomes an 800 Newton force. That's why tools are good. We like tools.
So, we ain't in static equilibrium no more?
Right now, we are talking about equivalent moments. We aren't talking about putting these things in static equilibrium. We're just showing that this moment is equivalent to that moment. Okay? So we're not having to resolve it into static equilibrium, but we're showing that by doing this over here, we're going to get this over here. Sometimes you got to do the concept part, and then we can apply the concept.
That's a pretty big force, 800 newtons on a tiny little screwdriver.
Yeah, that's why screwdrivers are cool.
Yeah.
That's why they strip stuff out too.
That's why they strip stuff out, exactly. And easiest way to strip stuff out,
Impact.
besides impact.
Using the wrong size.
Hmm?
Using the wrong size.
Using the wrong size is one button, yeah. That's always the case, using the wrong
Not
size.
applying the appropriate amount of pressure. That's my experience in the
Appropriate amount of
Is these people
actually,
don't know how.
the worst thing you can do is not be lined up.
Oh, yeah. Especially
If you're
with
not
the
lined up, you're not straight in, if you're off kilter, you're gonna strip, and you know, and that strips on, the same goes for opening bottles, opening any, if you wanna strip threads, put things on cockeyed. Don't, not good. If you wanna make Mr. Black really PO'd at you, we're talking serious PO'd.
Cross thread.
Cross-threading will PO him a little faster than anything else.
More effective than red Loctite.
It's not wrong. He's not wrong.
Yeah, but cross-threading, using a drill, not drag. He's just a little CBO. My daughter's the same way, my grandsons are the same way, sister. And then my poor son-in-law.
Is it personal experience, you know, that it makes him mad? You've done it to him before?
I try very hard not to cross-thread things, but my problem, fundamentally, my problem is if I'm trying to put in like curtain rods or things like that, I'm short. So to actually get up there to get it straight becomes a problem. And so it's not necessarily that I'm not trying to do it right and I'm being sloppy. It's trying to get into that particular awkward position to do it is a problem.
You know what's the worst? Putting metal sheeting on roofs, because you gotta have that drill just perfect, or else.
Yep.
it'll-
And you gotta hold it just
Yeah.
while that self taps.
Exactly. Exactly. So there's a lot of that kind of stuff that just comes fun stuff. So, you know, practical application of statics. It's not just book learning in my class, right? You cannot, you all cannot say that all you did was learn stuff right out of the book in my classes. It's not happening. So we're gonna open a valve. And we're gonna open a valve. And we're told that from the center or the valve stem is 0.15 meters.
Wouldn't that close the valve?
Close, open. Well, it depends on what it is, because
That's true. That is true.
hydrogen is cross-threaded.
Don't they use like left-handed threads on yours?
Yep, they do left, the hydrogen is reverse threads. There are a lot of things that you'll use reverse threads for safety reasons.
For some reason, my car battery has reverse threads, and so I had to change it, and I'm sitting there trying to do it, and then my mom does it the wrong way, and it works, and I'm like, what?
And for you guys, did you know that there's a difference between a female zipper and a men's zipper?
And what?
And buttons on a shirt.
And buttons on a shirt?
That goes back to like the medieval times.
There's a whole lot of weird stuff.
They used to have a winning button of insurance.
It's just the strange things in life. Alright, so this time we're gonna look at the resultant moment. And that's gonna be the sum of our moments. Okay, that's gonna be the sum of our moments. Now, in this case, because we're doing magnitudes and we're not necessarily looking at it, you're not going to be able to get direction from the calculation, okay? You're not going to be able to get directions from the calculation. So by looking at the picture, we know that the direction is going to go this way. Because the calculation is just going to be looking at the sum of the moments, which is just going to be RF plus RF. These two are the same, those two are the same, so we get the 2RF, right? And that's going to be 2.15 times our 75. And this will give us 22.5, and this is in Newton meters, and it's going in that direction. So by doing these, we can do a lot of different things. So I'm going to do this picture. Alright, so I've got an I-beam here. And I have a force that's being applied at this end. And we're given that force is a 3, 4, 5 force. We've got a force that's being applied at this end, and it's also a 3, 4, 5 force. We've got a 200-pound force coming off on this side. We have a 200-pound force going that way, and we're told that this is 1.5 feet between the two, and this length is 4 feet. And we're gonna, this force here, and we're told for the problem that I'm working that the force is 150 pounds. Okay? We're wanting to find the resultant moment on the system. Okay? We're going to want to find the resultant moment on the system.
The 3, 4, 5 is 150 pounds?
Yeah, this force is going to be 150 pounds.
It's 4 foot.
And it's 4 feet from there to there. And it's 1.5 feet from here to here. All right, this is a case where I don't know. I'm not using my matrix to be able to find which way things are going to go, right? But if we think about it, if I'm applying the forces like this, which direction is the torque going to go? Applying it like this, torque's going to go that way. All right, so the force, if I'm doing the force one, it's going to go that way. Counterclockwise is positive. This one is going to go that way, right? The 200-pound force is going to go the other way. So if you get the problem wrong when you're working on stuff, you want to make sure that you've got your directions correct. Okay? You want to make sure you've got your directions correct. Now, you give us a 3, 4, 5 triangle, so we'll need to know our cosine, right? Cosine is gonna be 4/5, sine is gonna be 3/5. And I need perpendicular distances, okay? I need the perpendicular distances. So if I do this, and I do this, my perpendicular distance, remember where we ended up in class, gonna be like, my things are not drawn right. But my perpendicular distance is gonna be across that pipe. So this is the R that I gotta figure out. So I need that R. That R is gonna be the square root of 4 squared plus 1.5 squared. It's gonna give me square root of 18.5, which is gonna give me 4.3 feet. So when I do my moment, I'm gonna have, I'm doing my moments, I'm gonna make sure I've got that, that's an R, I've got that one calculated. So they don't actually meet. Don't actually need it. Then I'm gonna go this way, and I'm gonna go this way, and I'm gonna use my 3, 4, 5 triangle. So I'm gonna have my 150, 4.5. Trying to do the same one. Oh, I'm just doing the, yeah. Doing the same picture, that's one problem. 4.5, and this is times 1.5. It's gonna give me the moment for this one. If I'm doing cosine, it's gonna give it to me in this direction. This one is 150, 3/5 times 4. It's gonna give me the one in the other direction. And those are both positive because I'm going that way. And this one is gonna be the 200, 1.5, and I don't have anything in the y direction, so I don't have to mess with that. And when I plug all this together, I get 240 pound-feet. And because it's positive, it's gonna go that direction, because I've accounted for the signs as I put it together. So this is the moment in the 150, 4.5. This is the moment in the x direction. This is the moment in the y direction. This is the moment in the x direction for that one. And then we just sum them all up together. And I have other problems to work, but I can't find the pictures. And that's like, I can't find that stupid picture. So I didn't get a chance to work them out yesterday. So I'm going to leave this with you guys. And we will be more ready on Friday to do some more. And this is getting us pretty darn close. We still got 4, and we haven't done distributed loads. So we'll probably finish chapter 4 like Monday, I guess. Monday or Tuesday, or Monday or Wednesday next week. So we get to chapter 4, and we'll get to start chapter 5 pretty quickly. But I've got to track down some pictures for my other work problems. But that will let you guys catch up a little bit.
What is it? 4.9 and 4.6, or what you're saying?
I thought I shifted one.
4.9 and 4.7.
4/9, the 4/7, 4/8 are due on the same day, next Tuesday.
Okay, I thought I shifted it though.
Wait,
You did,
no,
it said I
Yeah,
think it was
4/9 was
originally
shifted.
like today.
It's all due this
All
week.
that we do, like.
Yeah, but I thought I shifted something.
yeah, the next,
You moved 4/9
there's two, one due
to the second. or
today, one due Friday, but one due, or two due Monday.
When do you get it?
There's not one due today?
I don't think I didn't think I had anything due Monday, I thought it was
Yeah.
on Tuesday.
Friday, 15 problems, and the other one's 12 or both.
Yeah, there's, 15 and 12.
Okay, I'll have to look at it.
I'm looking.
One's like 2 plus hours, the other one's like, but. I just separated them into different